Hello dear listeners, my name is Alex and today I'm gonna talk about basics of social networks analysis. This video presents short theoretical introduction as well as practical guide to implement in VK social network. This is what I'm gonna show you today. First, we will speak a bit about motivation for social network analysis. Second, we will answer a question, why is Wolfram Mathematica to perform such analysis? Then we will see how this can be done in VK, the most popular web social network in Eastern Europe. And some conclusions will follow. SMA found its applications in many disciplines. SMA is a useful tool for scientific researchers in anthropology, social psychology, communication studies, and many others. Businesses use SMA to support activities such as customer interaction, intelligence acquiring, target audience clarification, etc. SMA is also applicable to law enforcement activities. This technique allows to map covert organizations such as an organized crime family or a street gang. So, the need for SMA is really huge, and related methods are on the cutting edge of modern analytics trends. There are some key approaches of every social network analysis. SMA conceptualizes social structure as a network with ties connecting members. SMA focuses on the characteristics of ties rather than on the individual. SMA views communities as networks of individual relations that people maintain and use during their daily lives, so the relations are statistically valid. Wolfram Mathematica provides simple interface to access web queries. Since 9.0 version, there are useful methods for visualization of social connections, in particular a procedure called community graph plot. All of this makes Mathematica a perfect tool for our needs. Because there is no native support of VK, like Twitter or Google+, we will also need custom libraries written by Vladislav Padev. You can download practically them below the video or from a original article on Hackathon. Okay, and let's start our activities from the opening of VK library, implemented in Wolfram Mathematica. So here you can see some methods begin from the VK method, which is related to gaining access to your user entry. And to realize this method, it needs some parameters. The first one is ID. This is your user ID, and I deleted it because you don't know your ID, and token the key to authorize yourself. So the idea at the current stage is to acquire your ID and the authorization key. So first we will go to vk.com, but to the dev partition for applications developers. Here we will try to create a new application. Here you can enter any title you like and click connect application. So I've chosen to receive SMS code. Okay, where is my phone? So here is my phone and here is the code. Okay, continue. Well, I've created a lot of applications of this, so VK denied me to create one more. But I'm sure you can go to the your library and you will not be denied. So you will see just the picture like the one before me now. Click on manage, and the idea is to take ID of the application from the command line at the top right. Here you can see ID, copy this ID later, maybe or now, I don't know. This is the ID which we will use in our further work. Okay, In order to get key, access token key, we will need to make a special query to the VK. As you can see, the URI is quite complicated, so we will copy paste this one from somewhere or write it by your own hands. And here you should change the symbols in there. Okay, with symbols to your ID. Okay, now everything is successful, and here's access token variable in the command line, so you can copy this variable. Okay, this is the empty variable. Copy, and use as token. Remember that you will get ID from the from this ID of user, not the ID of application. So now we have all the information we need to authorize in VK. Yeah. Okay, now let us try to extract some information from the VK using our data, and the first will be procedure to obtain username and user ID. You see my ID here. Okay, the response is here. Here's my last name and other information, ID and first name. Now let us implement procedure vkinfo, which led us to return not only a name but a photo in the request, not only of myself but some users, in two possible realizations. That's my friends list before, in particular list of their IDs. And here it's more complicated than all those procedures, which led us to choose what exactly to return. Okay, now let us return a list of my friends with photo, with names, and so on and so on. But it will take a time because some large amount of information needed. Okay, so we have extracted our list of friends. Here you can see friends ID. Because parameter photo was set to true, you can now see friends photos in the list. Okay, scroll. So it's time to get to something useful. Let us connect a procedure which can determine if there is mutual friends between you and the other person. And this is a very important procedure in order to build edge graphs in the future. So there are some options. It is possible to receive data from the procedural VK neutral in a clean format without any additional parameters of Mathematica list or without it. So these are the lists which consider the friends and all the undirected edges of graphs connecting you and your friends. And now it's time to find if there are some common friends between you and your first level friends. Then to delete all unnecessary duplicates of connections between you, your friends, and the duplicates of connections of two friends between each other. So only one connection must be used. Okay, building undirected edges list. Deleting all the duplicates. And let us run the creation of friends list or graph, but it will take a time. So prepare yourself to T maybe for 7 minutes. Okay, we have almost finished our procedure of graph building to represent the structure of my social network and friends connections. So let us use community graph plot. Okay, where is it? Oh, I have to zoom out because the number of my friends is pretty big. So in order to see them all, I should be prepared to scale the graph. Okay, what is it? So the distance from the center to the user is function of the quantity of mutual friends, sum of friends, appear to be in cluster, and some of them are known as the very large distance. And the man is the largest quantity of mutual friends with me is in the center. Okay. It is difficult to say something different, so I'll switch to the next type of diagram. Or by the solution as well. Here we can see good clusterization. Those are my friends from school. Those cluster. This cluster is cluster of my university friends and coursements. Okay, this is someone loner. And threads are the public organizations, activists from my university or close to it. A lot of them here is a few random people who somehow connected between each other. Okay, those are public activists from the human sciences departments of our university. So they connected separately. Okay, and those are network of friends who knows each other well, but a bit separated from my other circles of contacts. Okay. As you can see, there is no any friends who have only one, who have no one mutual friends with me. They appeared only in first step of graph. The second, only friends with two or more mutual friends. Okay. Thank you. In conclusions of our lesson, we have shown that social networking analysis can be easily implemented in Wolfram Mathematica. We have covered all the basics of VK API functionality and there are many possibilities for further development. So it is possible to update and enlarge the functions of existing libraries in order to achieve desired functionality. So I wish you good luck. So our lesson is over. Thank you very much for listening. Wish you good luck in your further social network analysis. Goodbye.